Okay, so now recording works. The lesson is to be recorded and will be available on vCamp as usual. So as I said today, I am going to continue discussion about the structural data, about LINQ integrated query, about query and method syntax, and general about the link to object. Next lesson. The goal of the next lesson will be discussion about the structural data, but in context to access to real external data. As an example, we'll use SQL database, SQL database. So let's go to the examples in the code. At the very beginning, I wanted to ask you to ask some questions. But where I have the questions, just a second. I mentioned about the external data. So at the very beginning, let me ask you what it means. What is external data? What is external data? The question you will have in the chat. As you can probably noticed in your responses, I have added a new comment, new column with comments. So I hope it will be the comments will be useful for you. So I wanted to avoid some questions that we are asking and asking again many times. Now I've organized my screen, and first it is for each example. You remember that last time we started with discussion about the for each. Let me close all the document. We'll get back to this picture. It's a very important picture, but now it is too early to discuss it. But I want to go to the for each example, and your question. The question for you is: what is for each? What is for each? Wait for a second. Okay, now, what is for each class in terms of the language? What it is? What it means actually in terms, but in terms of the language. Let me recall that we discussed it in the example we have on the screen LINQ query syntax examples, and here, for example, is for each. Therefore, I'm asking what it is in terms of the language. And actually, the next question, very important question, is no. I'm not sure if there are good answers. What is return from the for each example? See on the code. We discussed it previously, but let's get back to this particular topic again, because I think it's important. So here we have a variable that is just a string containing these words. Next we have a list, next variable, and here it is for each. So the answer for each, it is the statement. It is the statement, instruction. It is, in terms of the language, it is instruction. It's complex because inside of the for each we can provide a series of statements. Now we have only one, if, and in this if statement we are testing against the first letter of this of the item of all of the words, and we are adding to this list appropriate word that starts with G. So after joining of the words, we are returning. Let's try to find unit test. Find all references. Because in unit test, I'm expecting to have appropriate answer. So answer is grape. For each example, returns grape. So it returns a word, it returns a string. It returns a string that contains these letters, and actually it contains the word grape. Get back to this letter and to this example. And here you can see next one, query syntax. We discussed it previously, therefore it is easy to get activity points for you. What is this from? This part of this of the example. What this in terms of the language? How to call it? It plays special role, and actually we must take care about what it means. Not only syntax for us is very important. For us, the most important thing, it is semantic, it is meaning of the right side of this equation. Yes, you are right. It is expression. It seems that a lot of you will get activity points, but next question is, what is return? It is next very easy question. What we are returning from here, let me analyze the code. Again, we have the variable containing the words. Here we have next variable. Now it's not list. It is just enumerate. I enumerate. So it's abstraction, instruction, generic type. But on the right side, we have expression. And this expression contains keywords from where select. And we can recognize, for example, here that assuming that where means something like if, you are checking the first letter of the word. Next, we are joining and returning the value. So the answer is of course grape. You can remember it also from the unit test, but the next question for you is why we need to like iteration constructs in the language for each and from. What is the reason? But don't provide me explanation, just one word. Because we can see that the result in the test, I have unit test on the right side, but I've got lost mouse. Where is my mouse? On the right side. You can see here that also from the query syntax we are getting the same result. It is exactly the same result. Therefore, the question is why we need two independent constructs, two independent semantics, two independent syntax. The question is, we can recognize on the screen that the syntax is completely different. It's clear because different we have different keywords, for example. The question is if the semantics is exactly the same. I'm asking about it because it is revolution. It is completely, it provides a revolution because it seems like a stupid and no reasons for something like this, that we have two syntaxes, but it means more or less it means the same. And the result of for each and query syntax are exactly the same. So the functionality looks like similar in this case and in this case. To distinguish the difference, let's dive into this method, query syntax side effect. Make it larger. And the question is for you. Stop the discussion. The question for you is, what is on the right side of the in? Here we have in, and maybe you remember about the requirements. What is on the right side? What is on the right side? But especially expression. But I'm asking about the type of the expression. Yes, you are right. You are right. It's expression, but if you can provide also the information about the type of this expression, what is expected here? Usually, if you know or not, usually we call this expression as a data source. In this case, it is array. It is array, but data source means something broader. It means that I previously asked about the external data. It is connected with the external data. It is something that we. So now the question for you is, what is required? What is required for the value on the right side of the in? What is required here? You said that it is expression. It's okay. If you provided information about the types, it is also okay. But now the question is what is required? To discuss what is different, let's dive into query syntax side effect and ask me the question. Probably you also should recall what we return. What is the result of this method? We also returning strings. So I am not asking about the type. The type is obvious. The type we know, but the question is what is the value? But now the difference is that array that contains selected words, we are processing using this expression. We call it language integrated query. So the query here, it is a hint that it is a word that stress that actually it's something that is similar to databases, because about queries we are talking in context of the databases, especially SQL databases. If it's a database, so the query means that we are going to express an operation that must be done against the data in this database. But additional after processing here we don't have databases. Here still this is variable. It is an array of strings. So it is not variable. And we are processing this array. But after processing the variable here, we are replacing the value of the Second is actually third, because the index starts from 0. But so we are replacing this value by the word peer. So actually it doesn't, the word doesn't start from G. Still we are joining and returning. What is the answer? The answer is that we are getting empty string. Why we are getting the empty string? What is the reason we are getting here empty string from the query syntax side effect? It looks similar. So after processing here this array, we should get the same result as here, but it's not true. Actually, we are getting empty string. Therefore, we must ask, actually, are you still writing? It's too easy. Stop writing. Next question is, what is contained in the value referenced to be the word query variable? In the value referenced by this variable. Here, it's a variable, this word query, and we are assigning a reference to an object. IEnumerable is just abstraction. It's interface. If it's interface, therefore we are expecting that the word query is a reference variable. So we are assigning a reference to an object. Here must be an object. It is object of string, but the most important thing is what is the it is really string. Do you think it's really string? Of course no, because here we are saying it must be IEnumerable, and there are many types that doesn't that are no string. Let me recall that string, big definition, string is sealed. So it is sealed class. Therefore, it is impossible to derive a new type from the string. It is impossible to derive. Let me switch the type of the meeting to enable your mics. So string is its concrete type, and because it's sealed, we know that it's impossible to derive new type. It is impossible to inherit from string. But here we are saying that the result must be IEnumerable. Of course, string is also IEnumerable. Also, it's very important that it's also IEnumerable. But it is not limited. Here we are not limited to provide only string. Answering the previous question is that actually we are not executing the expression that we have in the line starting 38. We are not executing. The next question is why, instead of LINQ expression execution, it is converted to object. So it says everything. Here, we are not executing the expression we have on the right side of the sign. We are converting into an object and assigning reference to this new object to the word query. Therefore, we are not executing this expression. It is the reason why we are getting here string empty, because this expression must be executed somewhere over there, because after finishing of this method, we must get string. It is concrete string, concrete type. Therefore, we must get a value of the string. The object must be of type of string. But from this line doesn't say so. It doesn't mean that it must be referenced. Here we are. So the operation, the execution of this expression is, I think, it's very important for task 3. So make sure that everything, and actually for the next lesson. Therefore, I think for very important thing is that you understand what happens here. So we are not executing. We are just converting. So compiler converts it into the object, and the object reference to this object is here. The question is where this object is executed. Where the object is, when and where, exactly where, because finally at the end of the day, we must remember that each operation must be triggered, must be started somewhere, and we need exactly the point in the code that is responsible to start new activity, new action. In this case, execution of this expression. As I said, we can assume that it is somewhere over here. But next question is, so when it is for you the question when, and it is enough to say not when but where it is executed. Who is responsible? Also, not who, but rather what is responsible. Let me recall your definition, and let me recall our discussion about the complex data and structured data. So the examples we have in the structured data, and here it is iPerson and ICD catalog. It is interface, but so it is abstract. To create an object, it must be implemented by an object. So the concrete class must inherit from ICD catalog and must provide all the operations. And in this case, we are talking about the complex complex type. It is complex because all the members, we can get access to all of the members using the selector operation. So actually here, providing the members, providing the property, we are getting a setter. Both are something like a procedure, special procedure. Therefore, it is important to distinguish many different special procedures. In this case, the special means that we can assign value and we can read the value using appropriate method. So the getter method is used to read the data from internal variable. Set, it is a method that we can use to assign new value to the same variable, but still we can use selector, and we can call appropriate selected method, getter or setter. But we can get, the most important thing is that we can get access to all of the members using the selector. In this case, the selector is just a dot. In iPerson, it's different because we can get access to these members, but it is impossible to get direct access to the members that starts from this property. From this property first, we are getting enumeration. But in this enumeration, we are using catalog, ICD catalog, and actually we need to browse to get access to selected entity, to selected item contained in a value described by a type. Therefore, we can distinguish two types: reference types that we are using to browse, references we are going to browse to move our access point from item to item, and type the complex type when we are using selector. Actually, we have two types that has that complex. It is class. Oh, many types. But let me mention about the classes. Interfaces. It is complex because we can get access using the selector dot, and also arrays. In an example, we have an array, and using appropriate index, we can get access to selected entity in the variable. So we learn here that we are converting this expression into an object and assigning reference to an object. But where it is executed? Let me ask you next question, because now I'm going to answer the question when or well, where. Next question is why we need anonymous types. The next example is it's anonymous types, and we are using anonymous types, but still it is open question. Why? What is the reason we must deal with anonymous types? Can we do the same with the named types? So where it is executed? Let's dive into definition of toArray. What is toArray? Big definition shows that toArray, it is extension function. It is static extension function. But here we have IEnumerable as the parameter. Therefore, toArray is not aware. toArray is not aware about. Listen carefully. toArray is not aware that word query contains not executed yet expression. It is aware that it is only IEnumerable. So let's go to the IEnumerable to see what the toArray can do. Go to definition. From this, you can see that the only possibility for the IEnumerable toArray, it is to call this method, getEnumerator. This is the only method to array the where that are provided by the value. So here the word query. Word query contains a value. It is a reference to an object. And what we need is that the object must provide enumerable interface, might provide functionality that is defined by the enumerable. Therefore, toArray calls this functionality. toArray calls this functionality. Of course, we can ask what functionality is assigned to this method. Now we are talking about the interface. It is abstract definition. Therefore, from here, we don't know precisely what operation is associated with the getEnumerator. We only know that as the result of getEnumerator, we must get an object that implements enuMerator interface. It is the only we can learn from this definition. The rest is up to the implementation. Therefore, if here from this LINQ query expression, we are getting an object, and this object provides enumerable, and this enumerable provides getEnumerator functionality. So the author of the type concrete, it must be concrete type, so it must be implemented, and it must be implemented to convert the object into an expression, back into an expression, and start execution. And after starting execution, we can return enuMerator as expected from the getEnumerator. Therefore, we can say that toArray converts this expression, converts this object into an expression and executes this expression as a side effect. It's just a side effect. It is the result of implementation of the enumerable interface. Finally, it is executed here. Where is the dot? Where is the selector? It is selector. But toArray, it is not a member of the type, because the word query, it is enumerable, and we know that enumerable doesn't have method toArray. Let me get back to definition of the extension method. Extension method is a static method, nothing else. It is just a static method. The only what us is that we can use the call syntax as it is for the instance members. So from this 42 line, it seems that toArray, it is an instance member, but it isn't. And for us, the most important thing is here that actually it is selector, but it's not real selector. It is not real selector, but it works like a selector. Finally, we are calling getEnumerator from enumerable, and this enumerable, it is assigned from the word for the word query. Okay, next question is related to the anonymous function. So what is the reason? First, to postpone, first, to do so many different things. First, to convert the expression into an object. Next, to execute, to convert back to expression and execute the expression. It's easier to do something like this for each. Without all of this combination, without all of this additional functionality, let's get back to the query syntax. Sometimes this line could make problems because most of the software developers are not aware about this, that after modification of the data source, the result could change because the expression is executed not as expected in line starting 38, but in lines 42. Forgetting about it, it means that it is very hard to guess why the result is string empty. So there must be a really good reason. There must be a really good reason to do something like that. It is not to make our life easier, definitely. Of course, the question is what it means. What do we expect to make our life easier? But in this case, definitely things are more complicated than in the example here, in the example above. Query syntax, you can see here and here. Some people trying to explain it that from it's more compact, that we need, but forget about it. What it means is more compact. So we need less letters. So the string is shorter. It doesn't mean it's nothing for the development. You can forget about it easily. You can forget about it. But there is one very important reason. Let's imagine that the words, this variable, it is not in memory variable, that it is representation of the database, that it is just, for example, a table in the database. Calling this for each, it means that we must fetch all the items from the database and put these values into the memory. You have two problems. If it's huge database, if it's huge table, and there is bunch of values, the problem is, of course, the memory. If it's possible. Second, it is also problem with time, because if the database is it's in a different location, so we must get access to this database using the network. Network means communication. Communication means time. Therefore, fetching all the values from the all the values from the database needs a lot of time. Could need a lot of time. I think the important word here is could need. It is not always in all scenarios. It is a case, but it could happen. But we have planned, we have designed all the technology we are using against the worst example, not the best example, on the worst case, not the best case. And the worst case is that the database is far away, and we must get access to the database using using the network. So what is the revolution? A revolution is that in here, in this statement, we are talking about the iteration. We know the iteration from the very beginning of software development. It is one of the first concepts that we have in all of the languages, iteration. If the language doesn't provide special statement for the iteration, we can use goto, and we can loop use conditional and go to instruction to implement iteration. But here, this we call selection. So we have select, and after the selection, we can apply any further operation. Of course, here we don't need any additional. We don't have any additional operation. The only what we are expecting is selection. Here we are using conditional to select, and here we are using this expression. So the revolution here is that instead it is the reason for the from. Instead of iteration, we are using selection. Select first, next proceed, next any operation applied to the selected items only. In the for each, we can get all the values and apply operation to all of the items. Of course, it is here, if you are talking about the memory, it is not very important because everything is here. So actually it is, as I said previously, it is just complication. It is more complex. We must remember about side effect. But try to imagine that words, it is a database. If it's a database, we can, this expression as an object, convert not directly to the expression, doesn't make sense. We must convert into the query, into the database query, into SQL query. Converting it into SQL query first, second, sending the SQL query to the database, and executing the SQL query on the database engine, using the database engine, we can get back only the values that we need, so that are selected by, for example, here by this. It is a good question. What this in the terms of the language? Of course, we can distinguish the sequence, distinguish the syntax. So we can distinguish the where keyword. After that, there is a variable, and for this variable, we are applying indexer and comparing with the selected letter. But it is actually, it is meaning. It is not. Answer in terms of the language. In terms of the language, we'll try to prove it. In terms of the language, it is, so here the word, this whole line means that it is method. But on the right side of the word, here we have a delegate. We have actually it is also a method, and the method must return true or false, because we are using this method to compare values and actually to apply a condition. So get back to the next. So what is important to remember? First, that LINQ expression is not executed. It is converted into an object. It is first. Second, that this could be executed inside of the memory, but in all of the cases, the execution on any operation that we are applying to this object happens during the selection, executing of the selector, and actually calling the expected interface enumerable and calling the method getEnumerator. Therefore, everything, the behavior of this object depends on the implementation of this interface enumerable. Therefore, enumerable is very, very important for us. It is crucial for us interface. This implementation of this interface, it's important. So let's go to the next example where we have query syntax. Anonymous types. You can see that now we have variable customer, and this customer is still array, but in the array, entities, items of the array are instances of the customer class. After picking the definition, I don't expect something special, but you can see that it is just complex type, 3 properties. We can distinguish 3 values, 3 names of the properties, and the names of the properties here is used to assign values for city, for name, and for revenue. The types we can recognize from this type. So here we have concrete type. It is not anonymous type. And this array, it is also concrete type containing concrete elements. But customer query, it is variable that refers to the expression that returns select. Select means that we are executing a method that creates new objects and adds this object to a list, to a collection. Actually, usually it is collection, but it is not required. It's collection. What is required? That it's returned from the word query. It is enumerable. So here we also expect enumerable. Not sure, or maybe you can see on the screen that that it's anonymous type. Okay, but we expect that it still provides interface enumerable. It is also enumerable. But because we don't know the type internal type of the enumerable. Therefore, we cannot provide here concrete type. It must be generic. It is generic, but it must be anonymous, because we cannot define the type of this of the elements containing in this. So the question is, here we are using something over here, something over there, that we are creating anonymous items. Can we use in this place? Can we use in this place named type? This is the question for you. Can we use a named type in line, in this line 53, instead of anonymous type? Let's see on the results. Actually, we are selecting all this, all the customer that what is this? City called Phoenix. City is Phoenix. So we can see that two elements here meets this condition. Actually, it's this condition resolves as true. So in here we can see anonymous type expect. It is here we are only checking that the LINQ query syntax example anonymous types returns these values, name and name3, name1 and name3. It is in compliance with the anonymous type, because we are returning only name, name1 and name3, and revenue. You can check that everything it's correct. We can test this way, but the question is, you said yes, that yes, we can. In this case, let's try do it. And just return customer instead of here. Let's do it something like this. We can see that it works. It's true. But let's back to language integrated query behavior. Let's try to imagine. that this expression. So the answer is, in this case, it's correct. The question is if it works. Let's check it. I'm not sure. Run test. Can we see the result? Windows. It makes time. It needs time. So after from the result, we can learn if it's possible in this case. But my question is more general. If it's good approach, if we really really should do things like that. Okay, what is the result? As you can see, it works. Still, it works. So we are over here. But why is wrong? The wrong is, try to imagine the customers. It's not internal variable. that it is, for example, table in the database. Using something like this, it means here that we must get enumerable and customer. What is wrong with that? If the custom query, it is the table, it must be aware about this type. It must know this type. It's impossible. It is external database. We are using internal types. We are using selected language. Customer in this language doesn't mean the same as customer in, for example, in Java or something, different languages. Therefore, in case we are dealing with this, databases, we should avoid using something that it's well known only as internal part of the program. In this case, for example, methods, types, things like that. We must avoid it, because it could work in case that we are applying this expression against the internal variable, but in case the variable represent external database, and here in the select here we will convert the expression into SQL query and send to database. It is impossible, because in database we cannot assume that the database knows the customer type. Doesn't mean that it knows the customer type. So it is anonymous type. Avoid things like this. So let's return of this. The good example you can find. Yes, is a good example. Usually, always try to use anonymous types. Use the anonymous types because the language supports anonymous types, because the language knows definition of the anonymous types. The only difference for us is that we don't know the name of the type. It is the only thing, but the definition of the anonymous types is well known by the compiler, and the compiler can use this definition to convert an expression, internal expression, language integrated expression into the SQL query. Let's ask about next topic for us. It is the expression, LINQ expression that it's marked on the screen. We call query syntax. Syntax means that it is something that is related only to the syntax, not to the meaning, not to the behavior, but only to this to the syntax. But another syntax, we know it's method syntax. For the method syntax, we are using extension method. So the question is, why we need extension method? What is the reason? But in the meantime, we are trying to answer this question. It's a very, very difficult question. But where's example? LINQ method syntax example. Here's a class that it calls LINQ method syntax extension. An example, let's start from this line, 27 and 28. You can see that that the variable word query is assigned here, but because the definition is duplicated, it's impossible to provide two definitions of the same variable. Therefore, I must comment one line, selected line. But the behavior of the method syntax in all of the cases are exactly the same. Method syntax, go to find all references. Let's try to find unit test. And okay, having this unit test, let's execute not the first, but second. Sorry, it was this one. So I haven't changed the unit test, but I've changed the expression. Here's the expression, and let's see the result. Run the test. Of course, you know that the test is it's green. Oh, it doesn't work. Okay, there's something wrong with this unit test. Again, method single. Method syntax, this one. Okay, it doesn't matter. Don't waste time. We know that it is exactly the same. It is exactly the same because we cannot change the language. Usually, the expression is something like that. So we have operations and operator, and we can also use we can also refer to the functions, to the methods that returns a value. Here it is exactly. Here is exactly also the expression, but in this case we are using methods. For example, where method. It is a method. We know that it is not instance method of the string. It is not instance method. It is just go to definition. As you can see, it is extension method. Next question for you is Control-C. Why we need lambda expression? It is extension method, and the first parameter is IEnumerable. It's IEnumerable, therefore we can apply here. So comparing these two lines, 27 and 28, we can try to find some similarities. Words, it is data source. Here we have words, and here also we have words. So it is data source, where here it is keyword, but here it is name of the extension method. Name of the extension method. Next, this method has a parameter. This parameter, it is lambda expression. Lambda expression, therefore I'm calling, why we need lambda expression? What is the reason? The next question for you, because I see that you know. What is the LINQ extension method? LINQ, language integrated query extension method. Up to now, we call all these methods as extension method. But now I'm proposing a new name, a new term, language integrated extension method. So it must be a special kind of the extension method. What is the lambda expression? Lambda expression is just, it's a method. It's an anonymous method because we don't have name, but we are providing all the parts required for all of the property, for all of the methods. It's parameter, here it's parameter, and it's the block. It is sequence of statements that must be executed using this this method. Because we cannot provide a method as a parameter, here we are creating a delegate. We must create a delegate that refers to the method of this type, this delegate. Let me show you definition. No, this one. Sorry. Here you can, maybe it is not clear. Can I make it larger? Oh, now it should work. You can see that here we are expecting function that returns Boolean, returns logic value. It returns result of the comparison of the first letter, and the parameter, it is string. Actually, word must be string. It should be provided. It should be provided by the where. This kind of methods we call predicate. We call predicate. So the question is, when this method is executed. When this method is executed. Of course, where is executed? Where is executed over here against the words. But the question is if it's really executed, because the method syntax side effects works exactly the same. So here we are getting empty string from the method syntax side effect. Therefore, we must guess that this right side of the assign is not executed. It is exactly the same as in the previous example. It is converted into object, and the reference to this object is assigned to this variable. It is not executed. Execution is postponed. That therefore we are talking about the from syntax and method syntax. Both mean exactly the same. For both, we can assign exactly the same meaning. Exactly the same meaning. So next question for you, it is I must go to a special example to provide you next question. So let's now stop the discussion to make sure that you will not answer the question. What is the why we need lambda expression? For example, it's possible to use here named method. The answer is the same is in the case of the anonymous type. Of course, no. Because if the words it's data source and represents table in the database, we should not expect, so where must be executed there. It must be executed using the SQL database engine. It must be executed remotely. We must convert where into the SQL query and send the SQL query to the database and execute this SQL query against this database, returning only the values after that. But of course, we must find a point where this conversion is made. But so exactly this method must be executed inside of the database using the database engine. Therefore, it must be converted into an expression that it's available and we can use as a query, as part of the query. So we must convert also this method, this predicate, into the part of the query to make it possible. Of course, it's impossible if the text is spread around the program. Everything must be in the one line. Everything must be in the one line. In this case, compiler is able to convert the text that we have in the one line, can convert into the SQL query. If the text is spread around the text, around the program, it's impossible. It's impossible to do. I know that you don't have background related to the parsers and to the compilers and things like that, but you must believe that it's just impossible. Therefore, the first assumption we must make that to convert something into an expression instead of execution, we need everything in the one line. If we are referring to the named method, it's impossible. It's impossible. First, second, we should not assume that the database has this method because the method it's available only for the program, inside the process where the program is executed. So the question is, next question is how to distinguish, how the compiler should distinguish. It is also the question for you, how you are able to distinguish expressions. It looks like typical expression. How to make sure that this expression is it is translated into an object instead of execution. In case it is executed, we don't have side effect. In case it is converted, we have side effect. So you can see that the result could cause errors in your program. Therefore, we must be sure what happens. Of course, for this first question, it is first possibility where we can try to find an answer. It is to define special variables that are dedicated only for databases. But it means special variable. What it means special variable? In all of the cases here, we only assume that the variables provide enumerable interface. And we can use, against this interface, we can use extension method, where definition of the where, F12, proves that the first parameter, it is enumerable. Therefore, using this instance syntax of calling a method, we are referring, compiler actually converts the variable as the actual parameter of the method. It is what compiler do. For us, it doesn't matter, but we must have answer to the question where conditions that actually looking at the program, we must be sure or not that something is converted or executed. It makes difference. First, we can see that where, go to definition, is from IEnumerable class. It is implementation of this method is inside this class. Therefore, execution of the getEnumerator using this selector causes that we are calling getEnumerator that is implemented in this class. So first we can assume that to have language integrated query method syntax, we need all the methods from this class to make sure that still we are talking about the language integrated query. Second, everything must be in one line. Everything must be in one line. Therefore, all the predicates, all the methods must be provided, must be defined as a delegate, as lambda, as anonymous method, as using the lambda expression tree, lambda expression syntax. Sorry, it is, and still we don't have, we are not sure. Sometimes compiler could execute instead of translate. So take care about it and take care about it. It is now very important. It is very important feature of the language. I don't think it's only this language. I am pretty sure that in other languages we can find something like that. I'm not sure, but because, what is the reason? The reason is that instead of having two programmers, one SQL programmer and one C# programmer, we could have only one C# programmer. And we can say that this programmer is able to get access from the database without using SQL. Of course, the question is, who is responsible? Because at the end of the day, the database must get SQL query. So the question is, who is responsible for converting expression that we have in the code to SQL query that we are sending to the database, because this conversion must happen somewhere. So someone or something must be responsible to do it. Okay, it is the idea. As long as we are using variables, data sources that are only variables, and these variables contain values against concrete types. So this technology we call language integrated query to object. Here we are applying a language integrated query against. We are applying against the object we have at runtime. We have in the memory. So everything happens in the memory. Always the conversion into the object happens during the runtime. Here, compiler is only responsible to provide appropriate text, to provide appropriate operations that runtime will use to convert this expression into an object. So the object is created at runtime. How it is created, it depends on this part of this line, language integrated query. The language provides, now it is a few words about the language, because we have a couple of minutes, so we can talk about the language, because language provides you some features that we can use. It is not precisely the language. It is environment. So the catalog. Where is catalog? Catalog provides a language integrated query here in this folder, language integrated query. Let me enlarge it. Language integrated query. You can find this 4 files. First, that it's root. We can see that it's just a picture. This is just a picture that looks similar as tables. We can, as a definition, we can apply against the SQL databases. But now we are not talking about the SQL databases. We can talking about any external data representation, an external database, an external device, an external source of data that provides structured data. Structured data means that we have complex data, CD catalog entry with the fields, and we have references to another complex types. It is not type; it's just a table. It is just a picture. So we can graphically represent contents of something. So it is next step how to make this functionality similar to functionality of the database. Together with these tables, under the cover, under the hood, the compiler generates, not compiler, it is a special tool that it's available as a part of Visual Studio environment. It converts the picture into a text. So it translates into types. Here we can find types. Of course, it is not necessary for you to understand everything here because it's auto-generated. You only need to understand the process, the scenario. In this scenario, we are converting a picture that recalls a content of the database into the definition, into the types. Because everything now it is executed and realized inside the memory, we are calling it in-memory object model. And therefore, we don't need to think about the mapping between the external world and the internal representation of this external world. But in the task 2, for you, it is necessary. Therefore, the next lesson we spent discussing how to map, how to solve how to use this mapping between the external world and the internal representation, because always we are applying all the operation against the object we have in the memory, in the process. To get external data, we need to ask external data source, sending to this external data source a query. And doesn't matter if it is SQL query, of its another source, for example, not SQL database. There are many cases, many different external data sources. For us, it's not important. For now, it is important that to get data from any external source, we must send something to this data source, something that contains query, contains description of the data it is required. Here you can see that it's partial definition. Therefore, we can provide our special functionality. Here, for example, we have catalog, personal table, and we can provide special functionality, custom functionality, not auto-generated, that we can use, for example, to get access to the data. And here you can see that this data behaves as the data source. This, it means that it's catalog of its class personal data. So actually personal data, personal data table, it behaves like a table in the database. This means that we are referring to the object, current object of this type. And on the right side, we are expecting implementation, we are expecting IEnumerable. Okay, it is your homework, how to prove that this means referring to an object that implements IEnumerable, here, of course, we can apply the same for each statement as previously, but it's also possible to provide query syntax, or here it is method syntax. In query syntax, additionally, you can find our references. It is my last sequence, last sentence, sorry. Here you can see that we are using creating new object and applying this, using this method to get the result. But in the catalog, we can see that in this time, we are not returning string, but we are returning an object that implements IEnumerable. Therefore, here, we don't have selector. So there is no place where to execute this expression. And here you can prove that the type, it is get type and return type, and the link, the name of the type you can find here, where enumerable iterator. So it's not string as is expected. In the next line, you can prove that that we are getting something LINQ object, and the expression is executed over here. Okay, I think that it's all for today. Thank you very much. So I'm turning off the